Hello, Professor. My name is Dhanush, and this is for the final phase 5 Enron email analysis, a big data analysis using Hadoop, MapReduce, Hive, Spark, and BigQuery. So to start with, I have the following contents here: a basic introduction of what's happening and what's the project about, which includes about Enron Corporation, problem definition, and dataset. Second will be analysis of based on different big data tools, for starting with Hadoop, MapReduce, Hive, Spark, and BigQuery, and at last the conclusion of what I have taken away from this project. So to start with the introduction, the Enron was actually a company formed after the merging between Houston Natural Gas and Internorth Incorporation. The company was also named one of the most innovative companies by the Fortune magazine. The company was so big that its share value was always a high of $90.56. But by the end of 2001, it was revealed that the financial condition of whatever the company has right now, an all-time high of price $90, was actually a planned fraud. Enron then filed an bankruptcy on December 2001, and its stock closed at 26 cents. So this drastic fall of price from $90 to 26 cents was something which interested me towards this particular data set. So the problem definition which I took for this project was when I was reading through it, there was an article written by the New York Times which says that MarketWatch, a self-inflicted wound, aggravates angst over Enron. This was actually a leak to the press from the company, and I just wanted to know who frequently exchanged emails from the articles from the Enron company, and to check who were the employees who were more active when it comes to exchanging emails. So the data set for this was taken from Kaggle website. The data set has 500,000 email documents, and all these documents are actually of the employees who were actually working in the Enron, the 150 unique employees of Enron. So before I start my analysis, I just wanted some of the points to remember throughout these slides, which says that in order to get the problem statement analyzed, I had to focus on the sent and the email folders which are there from the data set. The sent and the email and the inbox emails helped me understand how many emails were exchanged and who were the employees who actually sent most of the emails, and who were the one who actually received most of the emails. I have extracted the subject line too from the email just to understand what was the most common topic among the emails which were exchanged. So to start with Mapper and the Reducer in action. This is a small slide which I've prepared to understand how the data was split. The data goes into splits and goes into the Mapper. The Mapper starts doing its job, and it divides all the emails with its values, keys and values, and sends the data to the Reducer, where the Reducer shuffles the data again and gives its own output, which will be used for the analysis. So the final output given by the Reducer is the sender's name and the number of emails he has actually he had sent to number of peoples. So k.main at enron.com had sent 16,735 emails at the time. So this is a MapReduce analysis which I have seen. The output format of the MapReduce job was the sender, tab, and the number of receivers. So what we see here is the sender's name, there's a tab, and then the number of receivers who received emails from Sally Back, for example. And the time taken to complete the whole job was approximately 12 minutes. which I would say was very long compared to the other data sets. That is because the data for this particular data set was in folders and not in any table format. And I have also tried doing it in a table format, and it took almost just like 4 minutes or something to complete the whole data and give an output of this. The mapper gives an output of the sender's name and the number of receivers. Moving to the Hive. For Hive, since the data was already in folders, and Hive, in order to give data to the Hive, it has to be converted into a table format. For that, I had written another mapper and a reducer program, which normally gives an output of a sender and the receiver with a subject line and an ID. So the output from the mapper 2 and the receiver 2 was taken here as an input for the Hive. These mapper 2 and reducer 2 Python files can be found in the files which have been zipped and submitted to your professor. The table name was then given as Enron emails. These are some of the queries which I ran on Hive to find the top 15 senders, to find the top 15 receivers, average emails received by the top 15 recipients, and the average emails sent by the top 20 senders, the number of senders with the same subject line. This actually helps in knowing me what was the common topic people used to exchange. And the time taken for run each of the query was surprisingly 10 to 15 seconds. This was the metadata, the schema, query editor, and the query when it is running. The results from this Hive query was I downloaded in the table format the top 15 senders and the counts number of emails, top 15 receivers, and the number of emails received, average of the top 20 senders, and the average of the top 20 receivers. Then next, the very interesting technology I came across while doing this was the Spark. I have used Spark version 2.3.0, and trust me, it's like a lightning fast analyzing tool when it comes to BigQuery. Each query took about just 2 to 3 seconds and not more than that to run. So I was very surprised with the Spark programming. The below is one of the query I've just shown here, the number of senders with the same subject line, and it just took about 1.6 seconds. Coming to the BigQuery, BigQuery is another very interesting. BigQuery is again another interesting tool which is provided by Google, and the table was actually uploaded. The output of mapper 2 and mapper and reducer 2 was actually uploaded into a table by forming a database on Enron and named it as Enron_email. And I actually added more data to the already existing data just to make sure that just to check the capacity of the BigQuery, and BigQuery was one of the outperformer among all the tools. Taking the runtime for each query was just about 1 second or maximum 2 seconds, so that actually beats Spark. And BigQuery actually gives a surprising results of the fastest query execution over the very big data set. And I believe this is the next big thing when it comes to the big data, the Spark and the BigQuery. Concluding this, the project has been an amazing journey into the understanding and implementation of different big data programming tools used in the real world to analyze a big amount of data. The most challenging part was to cleaning up the data and understanding the data set. Understanding the data set was very important for me in order to know how to solve the problem statements. The programming tools which were used were MapReduce, Hive, Spark, and BigQuery, and among all the programming tools used, Google's BigQuery seems to be the fastest execution in the queries and gives an output like within seconds. This was one of the comparisons which I've seen. just with respect to the time taken from each programming tool to execute. Hadoop MapReduce standing at 12 minutes, Hive took 10 to 15 seconds, Spark took 2 to 3 seconds, whereas BigQuery took 1.5 to 2 seconds to complete a query run. So that's it, Professor. Thank you very much for the opportunity, because I have learned almost 4 technologies with this, and I hope it helps a lot to me in my future job, which I'm going to take up in the field of data analytics. Thank you, Professor. Thank you very much.